Hello, my dear students. Welcome to the final year class. Okay. So, today in this session, you are going to study the multiple drivers in the VHDL. Okay. So, before going to study, just I want to revise that in the last classes, we studied about the data flow modeling. Okay. And the difference between the data flow modeling and the behavioral modeling. So till now we know what do you mean by the data flow modeling and the behavioral modeling. Okay. So today let us start the class with how to write the one program using the data flow modeling. First I want to show you how to write the program using the data flow model. Okay. Here you see uh, hmm, so for this circuit, you are going to write the data flow model. So you see here it is a XOR gate, and what are the inputs A and B, and the output is the S1, and this is which gate? AND gate and the XOR gate. Okay, A, B, C, D are the inputs. Whereas S1 is the output for this one, S2 is the output for this gate, and here a, B, C, D are the inputs. S1 and S2 are the in and out bits. Why? Because this is the S1 is the output for this XOR gate. S2 is the output for the what? AND gate. Correct. Okay, and Z is the whole output. And here S1 and S2 are the in out. Okay, and because this is input for S1 is input for this gate and S2 is input for this gate. Okay, so let us start write the behavioral data flow model. Okay, so what we have to write? So once again we have to follow the same rules to write the program. Okay, first you are going to write that 4 lines. What are that 4 lines? That is IEEE library arithmetic dot all the 4 lines first you should write, and next you are going to write the entity part, and next you are going to write the architecture part. Let us see first how to write the entity part. Okay, so we know that it begins with the keyword entity, correct? And afterwards what you have to write? Entity, and next you are going to write the name of the entity. So what I have taken here? Circuit and is. Okay, and next you are going to write the port. In the port what I have to mention? Inputs and the outputs. Okay, according to your circuit, how many inputs are there? 4 inputs are there, A, B and C, D. A, B, C, D are of the type in bit. Okay, and next what is Z? Z is the out bit. And what are the S1 and S2? S1 and S2 are the in out bit. Okay, and next is the end and the name of the entity. Let us hope all of you understood how to write the entity for this one. Actually there is no difference for writing the entity in the behavioral model or the data flow model. Both are the same. Okay, only the difference comes in the architecture that we have already studied in the introduction part of the data flow model. Correct? Okay. Now let us write the architecture part. So architecture part begins with the architecture and the data flow. What is this? This is the name of the architecture of entity name is. Okay. And next you should write the begin here. Okay. Here you have to write the begin of the architecture, and next we are going to write the output for this circuit one by one. Let us write the first output, that is S1. What is the output for the S1? S1 is equal to A XOR B. Okay, and next let us write the output for the S2 and gate. What are the inputs? S1 and the C are the inputs. Okay, S1 and C are the inputs. Let us write S2 is equal to S1 and C. Correct? And next, the final output Z. What are the inputs for this one? S2 and the C. S2 or C you have to write. S2 or D. Sorry. C is for S2. Okay. For Z. Z what we have to take? S2 is one input and D is the another input. So Z is equal to S2 or D. And the name of the architecture. Okay, you see it once again and try to write the program. First, you just take the circuit, try to write the program without seeing this. Afterwards, you verify the program. Then you will able to write the program. Okay, and similarly, you try the same data flow model for the different types of the circuits. Okay, okay. Now let us begin the multiple drivers. So that also we have studied already. What do you mean by the multiple drivers? Correct? What are the, so that means you studied about the drivers, not the multiple drivers. Okay. What do you mean by the multiple drivers? So what multiple drivers means, each concurrent signal assignment statement creates a driver for the signal being assigned. Okay, so we have studied about the concurrent signal assignment. What do you mean by the concurrent signal assignment statement? If the statements return after the process statement, that type of the statements are called out your concurrent signal assignment statement. The program written using the concurrent signal assignment statements are called the data flow model. Till now what we have studied, the how to write the program using data flow model. Okay, so here what happens, so in the concurrent signal assignment statement, it creates the driver. For each and every signal what happens, the other drivers are created. That also we have studied. Okay, but what happens here, when there is more than one assignment to the same signal, then what is the output of that signal? Okay, so here in the case of the signal has more than one driver, and a mechanism is needed to compute the effective value of the signal. Okay, I will explain you once again what do you mean by the multiple driver. Okay, actually we are using the signal. This signal is called what? This is a signal assignment statement. Yes, that is signal assignment statement. What is the work of the signal assignment statement? Assigning values to the variables. Correct? Assigning values to the signals. Okay. And whenever it is assigning the value, it creates the driver also. Okay. That is called what your driver that you studied in the previous classes. Okay, and here what happens, so for the one signal is it creates the driver and it is assigning the values. Okay, but here what happens in the multiple driver, you think that here the two assignment statements are there for the same variable. Okay, for the same variable, if you are assigning the values, so y is equal to a and b and y is equal to not of c, then what happens, for each output signal value is assigned and for each signal driver is also created. Okay, so that is why it is called the multiple driver. Okay, what do you mean by the multiple driver means, if two are the more signal assignment statement assigned a value to a single signal, then it creates a two or more drivers called the multiple driver. That means if you are having the two outputs, then it is creating the two drivers, or if you are having more than two, then it creates the more than two drivers. So that is why this is called the multiple driver. Okay, I think all of you understood. So even though I will repeat it once again, what do you mean by the multiple drivers? Okay, So we know that this signal assignment statement, okay, what is the work of the signal assignment statement? Assigning value to the signals, okay. Assigning values is nothing but what? It is actually evaluates this value and it is assigning, that is called the assigning values to this variable. Okay, here what happens? This y is, that means this only for one variable we are assigning, assigning the two outputs. Then what happens? It creates the drivers for the two variables. Then what happens? It is called a multiple driver. Okay. I will tell you once again because I want to clear it you. So here, so just you try to see this circuit. Okay, what this circuit contains? A, B, what this circuit A and B and C, and this is your AND gate and this is your NOT gate. What is the output? Z. Here, how you are going to write the program? So here you see I have written this one. Entity part is the same, that is ABC are the input and Z is the output. All of you know here, end of the circuit. Then how you are going to write the architecture part? Z is equal to what you are going to write here? So you think that I have taken as Z1 and Z2. But what I have to write? It is not possible to write anything here. How I have to write here? Z is equal to A and B and C is equal to not of C. Sorry, Z is equal to not of C. That means for the single variable, we are assigning two values. Correct? Okay. You are assigning. So, but it is executing also. But which one we are getting the output? That is the problem here. Okay. So before going to solve that, so here what I told, signal, for each signal what happens, drivers are created. If the drivers are created for more than one signal, then that is called what? Multiple drivers. Okay, the same thing I have written here. Let us read the uh, sentence once again. If two or more signal assignment statements assign the value to a signal, it creates two or more drivers called the multiple drivers. So here I already explained this example. Okay, in the short form also we have written two or more signal assignment statements is nothing but what? The multiple drivers. Okay, next comes the solution. How to solve this? That means here two values are assigned. Which value is going to get the output? Okay, to solve this, what we have to do means we have to use the resolved function. Okay, these outputs are given to this resolved function. So from this we are going to take the output. So that output is called the resolved signal. Okay, now let us move towards the one example using these multiple drivers, and let us say how it is using the resolved function and what is the output and all that. Okay, so let us study what do you mean by the resolved signals. Before going to study that examples, first let us know what do you mean by the resolved signal and the resolved function. Okay, it is a function used to select a single value from the multiple driver. Okay, till now we have studied that how the multiple drivers are created. Okay, then what do you mean by resolution function? The multiple drivers are created. From that multiple drivers we have to select a single value, that is called out the resolution function. Okay, and output of the resolved function is called the resolved signal. Okay, But if you want to use this resolved function, what we have to do means we have to declare as a resolved bit, that is wired OR bit or wired AND bit. Okay, in the declaration part, we have to mention this. It is a wired or the wired AND. Okay, then it is possible to find the resolved signal when it is the multiple drivers. Okay, and a resolution function is associated with a signal by specifying its name in the signal declaration, that is signal Y out wired or bit. Like that you have to declare to get the output. Okay, so now let us see the example. Hmm. So here so what I told, I showed the circuit. No, for the same circuit I have written here, that just now I have shown here. Entity of resolved function is. So what I have taken its name. I show you once again the circuit. Just you remember that circuit. Okay, for this circuit, we are writing the program. So just you see and write in your notebook, and afterwards you see the program. Okay, it is okay. For this function, first we are writing the program, and afterwards I will tell you how you are going to applying the resolution function and how you are going to get the output. Okay, so how many inputs are there? Three inputs are there, A, B, C, and only one output. That in the figure I have taken as that, but here I have written as Y. Because of this practice, Y, here you see out wired OR bit. What I have taken here? Resolution function that must be declared. It is as a and or the or you have to take or the and. So what I have taken wired orbit, and end. What is this? This is the name of the entity. Next, let us move towards the architecture part. How I have to write here architecture part? Architecture, data flow, and next what happens? Name of the entity. Okay, and here y is equal to a and b and y is equal to not of c. End data flow I have to write. So just you erase this end md is the wrong, so something it is coming, so you just remove this. Okay, only just you concentrate on only this thing. Okay, so you have seen that y is equal to a and b because two gates are there, and y is equal to not of c. So here what happens, instead of z I have taken y. If you want, you can change in the circuit, that is equal to y. Okay, remember that there is no meaning for this end of empty. It is by mistake, it is type. Just remove this. Okay, now let us find what is the output of this circuit. Okay, so here the multiple values are assigned, so multiple drivers are created here. Then how we are going to solve this? Using the resolved function. Okay, how? Using the resolution functions we are going to solve this. Okay, to solve this, what we have to do means just we have to assume the values of ABC. Okay, after assuming, then you are going to find the output. So whatever you are getting the output, no, that output is called resolved signal. Okay, I will show you here. So I will take the what I will take means I will take the some initial functions. Okay, so what are the initial values I will take means here I will take a is equal to 1, b is equal to 1, and c is equal to 0. So when you are taking that a is equal to 1, b is equal to 1, and c is equal to 0, what is your equation first according to your circuit? If you see this, according to your circuit, okay, first one is the AND gate, that is Z is equal to A and B, and C is not of C. So that means first one is y is equal to a and b. What is a and b? A and b is equal to 1 into 1, 1, and next not of c, that is also 1. Okay, so you are going to applying the resolution function. So in this resolution function, what happens, which one is the highest value, that is taken here. 1 is the highest, so your output is equal to resolved signal, where r is nothing but maximum value is going to taken here. So presently both are 1 1, so you are going to get the output is equal to 1. But here when I changed this b value is equal to 0, then what happens? Y is equal to 1 into 0 is nothing but this y is equal to 0. And what about this y is equal to? It is equal to 1. Here resolution function happens means, so here wired r is there. R is nothing but it takes the maximum value. That means your y is equal to 1. Now your y value is equal to 1. Okay, and this signal is called what? Your resolved signal. Okay, this signal is called what? Your resolved signal. Let us hope all of you understood this one. Okay, please try to read once again. Okay, but another one important point here about the resolution function. Okay, so if you think that you are having the multiple drivers, then if you are not using the resolution function, you are not able to get the output, then you are going to get the error. Okay, so a signal with more than one driver must have a resolution function associated with, otherwise it is an error. Okay, such a signal is called the resolved signal. Okay, please go through the video once again, and try to solve more problems. If you have any doubts, put in the comment box. Okay, we will meet in the next video.